metals and non-metals. எப்போதுமே நம்ம ஒரு டாபிக் எடுக்கிறோம் அப்படின்னாக்கா we must go through the topic tree. First of all, develop the topic tree. So physical properties. Take down physical properties. That is the first topic we are going to discuss about the metal and non-metal. Physical properties. That is point number one. Second, chemical properties. Chemical properties of metal. That is point number two. That is the second topic, chemical properties. And third property is how do metals and non-metals react? So how the metals they react with non-metals. Okay. So that is the third topic. And fourth topic is occurrence of metals. What is that? Occurrence of metal. That is how these different metals are available on Earth. Okay. Then fifth topic is about corrosion. So the fourth topic is about the ore extraction, ore concentration and metal extraction. Fifth one is the important property of metal, that is corrosion. Metals have the tendency to undergo corrosion. Corrosion is nothing but what? An oxidation of metal. Metal becomes metal oxide, is it not? So you have five important subtopics. Okay, that's all. So you got only five. So physical properties. When you discuss about the physical properties, you know very well metals are good conductors of heat. So this is an activity based on what? The conducting nature, that is heat conducting nature of metal. So what they have shown here, that is that they have kept a metal wire and it is clamped in a stand. Now, with the help of a burner, Bunsen burner, we are heating. And when you touch here, probably that is, you will feel a heating. So the heat is conducted, is it not? And not in that, you just fix a pin and wax. Now you can see the wax is molten and the pin will drop. Okay, so this is a very small, simple activity to illustrate that the metal is capable of conducting heat. And it can also conduct electricity. So metals are good conductors of electricity. Then non-metals are they do not, but there are some exceptions. For example, graphite is a good conductor of electricity, so that we can highlight as a that is exceptional case. Okay. Then mercury being a liquid metal. Okay, so that also conduct that is heat and current. Okay. Then you have the chemical properties of metal. So other aspects like what about the metal? When I that is a beat a wood like this, it will not create any metallic sound. But when you beat the metal, you will have a ringing sound. So that is metals are sonorous. Okay. So likewise, you should be able to distinguish between metals and non-metals based on the physical nature, right? Then when we go to chemical properties of metal and how these metals they react when they react with oxygen. So metals react with oxygen to form what? Metal oxide. For example, copper can react with oxygen to become what? Copper 2 oxide. Okay. Similarly, aluminum becomes aluminum oxide. And this aluminum oxide can be dissolved in HCl so that you are able to get aluminum chloride. And this aluminum oxide can also be dissolved by sodium hydroxide so that you are able to get sodium aluminate. Okay. And in the case of sodium oxide, that is the oxide of sodium metal and potassium, when it is dissolved in water, they give alkaline solution, and that is why they are called alkaline metals also. Okay. Then metal they can react with water. Some metals, for example, sodium, lithium, they can easily react with water, so that hydrogen is evolved here. Okay. But in some cases, metal can react with the steam. Okay. So in this case, for example, that is you can see the action of steam on a metal. So you've got the Bunsen burner with which you can burn it, and you've got the glass wool soaked in water. Now you've got the metal sample. So because of the heating, what happens that is the you can find the delivery tube here. So when the delivery tube that is for the purpose of passing the hydrogen. Okay. So this is by displacement that is the hydrogen is filled up at the top. Okay. So this is a simple activity to illustrate that that is how the metal can also react with the heat. And similarly, you have got the other properties like a metal A, and you have got some salt solution B. So now it can replace the, the metal part of the salt also. Okay. So about which I have already given a detailed video. So you kindly go through that. And where I would have discussed about the reactivity series, which is the speciality of this metal. So you can find here potassium, sodium, calcium, magnesium, aluminum, etc. up to gold. So down the group, you can consider this as a column or group. So down the group here, you can find the reactivity is coming down. It means gold is less reactive, whereas potassium, sodium are highly reactive. And moderately reactives are what? That is a zinc, iron, etc. Okay. So based on the nature of this metal, the reactivity tendency will be varying and they come down with the that is descending direction. Okay. Then so you need to explain about this reactivity series of metal and based on which, in fact, that is a metallurgy is also designed based on this reactivity series. Then how the metals can react and what about the non-metal? And before that, you should be able to um, arrive at the electronic configuration of metal. For example, let us consider noble gas helium. What is the atomic number? 2. So in the first shell, you have got 2. Okay. Similarly, neon argon, and you can add 8 every time so that you are able to get 2 plus 8, 10. So that is the atomic number of what? Neon. Again, add 8, so you will get argon, that is 18. So this electronic distribution can be illustrated like this, that is 2, 8, 2, 8, 8, like that. And when an element has 8 electron system, it is called, it is obeying octet rule of stabilization. So it attains the stability by achieving this 8 electron system. So each metal has a tendency to undergo or to obtain or attain the 8 electron system. For example, what about sodium? The atomic number is 11. So it can be 2, 8, 1. So 1 is left alone. Okay. So instead of retaining it, it can attain the octet stability by releasing the electron. Is it not? So that is why it has become Na plus and plus E. So here one electron is lost, and that is why the electronic configuration is confined to 2, 8. Now this sodium cation is more stable than that of the sodium. Are you able to follow? And that is why metal has the tendency to undergo oxidation. That is, removal of electron is called oxidation. Clear? Then, in the case of a non-metal like chlorine, they can withdraw electron, right? And that is why it becomes chloride anion. In this case, instead of losing 7 electron, they can easily take 1 electron and thereby attain the what? Octet stability. Do you understand this? So that is illustrated clearly here. Okay. So likewise, you should be able to that is completely write down the electronic configuration also of metal as well as the metal ion. Okay. Then metals have the tendency to, they have the electropositive nature. Electropositivity means what? Electron releasing nature. What about non-metals? They withdraw electron. Okay. So they are electronegative. So non-metals are electronegative. And that is why in a periodic table, you can find that on the left side, the metallic behavior is more. On the right side, non-metallic behavior is. Okay. So it means that is the metallic behavior decreases from left to right and down the group it increases. Okay. And vice versa for the non-metallic behavior also. And this is a small example of heating a salt sample on a spatula and whereas how this behaves. So the metal, when it is heated, what happens? So similar is a small activity. Likewise, they are explaining with the graphite rod the conductive nature of the uh, electrode. Here it is a graphite, even though it is a non-metal, but this is capable of conducting current. Then you should also able to explain the physical nature, melting point, solubility, conduction of electricity, all these properties as ionic compounds. So metal-based compounds, that is ionic compounds. Then occurrence of metals. So here, how the metals are present on the Earth's crust, and they are, available as ores and minerals, and they are extracted. These metals are extracted from these ores, and here you can find the reactivity series. The activity series we already discussed. Okay, so when the metals are highly reactive at the top, they are very difficult to what? Isolate. Okay, so in that case, we have because they are strongly bound, is it not? They are strongly active means strongly bound with other metals and other non-metals. So that is done by electrolysis only. So here the electrolysis is employed to extract the metal here because it is very reactive. Whereas moderately reactive elements or metals like zinc, iron, lead, copper, they can be done by reduction using carbon. Okay, and that is why that is even in Tamil Nadu that is even 5,000 years back it is said that the iron has been extracted. Okay, so we are expertised in this technology, right? And what about the silver and the gold? From time immemorial, they are able to that is make use of this gold. Okay, but only for the couple of centuries, the sodium, potassium, calcium has been isolated because of the high reactivity, and that too after the discovery of electrolysis. Okay, right. Then, what is ore? Ore, they contain important metal compounds, and these ores are dressed, that is concentrated further. So, gang materials are removed from that, and this is a chart that describes the steps involved in the extraction of metal from ores. Okay, so the metals of high reactivity they can be, the pure metals can be separated by electrolysis technique. Whereas in the case of metals of low reactivity, what are those silver, gold, etc., they can be extracted by that is sulfide. They are all sulfide ores. They can be roasted, and you are able to get the metal, and further it can be refined. So in between that, these are moderately reacting elements or metals. So we have got two types of ores: carbonate ores or sulfide ore. Carbonate ores are mixed with the calcination, that is with the calcium-based compound, so that you are able to remove the calcium carbonate and other gang materials. Okay, and metal here becomes a metal oxide. In the case of sulfur, it is removed as what? Sulfur oxide, sulfur dioxide. Okay, so that the sulfur can be eliminated as a sulfur dioxide. In this case, a carbon dioxide is removed. So carbon is eliminated. So in the carbonate ore, carbon is eliminated by calcination method. In the sulfide ore, sulfur is removed by as sulfur dioxide by roasting. Okay, roasting means நல்ல வறுத்து எடுக்கிறது. சரியா? Then, and the oxides of now you are able to get oxide of metal. So once the metal oxide is obtained means you can easily reduce it so that the oxygen can be removed. Reduction is nothing but what? A removal of oxygen. So thereby we are able to get purified metal. So this is a very important chart. You have to reproduce this. So this is also called the enrichment, that is ore concentration or ore pressing. And based on the metal activity series, it has been explained very clearly here. Then regarding the equations, I have discussed in detail in the video. You can go through that. If you don't understand, you can very well ask me. So similarly, that is extracting metal from the activity series, and that too have been point and blank. That is for every reaction I explained. And this is a very important that is question. That is, what is thermite process? So actually, this is used for joining the railway lines. Okay, so they use this manganese oxide and aluminum, and when it is mixed together, heat is there. given out, and thereby because of the heat they are molten, so that along with that you are able to mix this iron ores, so that you are able to get what the iron duly molten, and that can be useful for joining the railway tracks or tracked machine ports also. So about which I have released a separate video, and you please go through that also. Then regarding electrolysis, I have nicely explained in this video. You kindly go through that. Then about corrosion also, I have explained the activity and how the corrosion can be prevented. What do you mean by corrosion? The oxide film formation is nothing but over the metal is called corrosion. So metal becomes metal oxide. So what we are supposed to do? We have to remove that oxygen, that is oxide layer, that is called de-rusting. So metal oxide is the rust. So for rust formation, for corrosion, what are the important agents which are responsible for corrosion? Air and water. So when we remove both, so that you can that is avoid rusting of metals, especially that is we are losing that is the national properties like bridges and iron girders in a large scale if it is not properly maintained. So it has to be painted, so that because they are all these bridges, they are exposed to strong climatic conditions, strong weathers, So it should be prevented by giving proper painting. So in those days, you can see the wonder of ancient Indian metallurgy. This Kudub Pinar building, this pillar, iron pillar, even now it is totally free from rust in such a way that metallurgically it has been properly made, so that the corrosion cannot attack this ancient monument. Okay, so this is a very important lesson, and you've got some activity based questions and also reaction based question. You please go through that, and you are supposed to do the exercise. So once you complete the our video contest, then you discuss with me regarding the balancing of chemical English. Okay, right.